Hey guys, today we are doing exponential and log inverses. We have done inverses before, way back in Unit 1. It is the exact same, except we are doing them with exponential functions and log functions now, because we now know that exponential functions and log functions are inverses. The same two steps apply that applied way back in Unit 1. First, you switch x and y. That was always step 1. And step 2 is solve for y. This is how you find the inverse of any function, including exponential and log ones. So we're going to go through a few examples. So step 1 says switch x and y. You literally switch them. And now I'm going to solve for y. Remember, you always do the farthest thing from y first. So that's going to be this minus 3. I get rid of it with a plus 3. Now that I have it down to just the base and the exponent, remember, anytime you get an exponential function down to the base and the exponent, you can write it as a log. So that's going to read log base 4 of x plus 3 equals 3y plus 5. From here, I just need to solve for y, so I'm going to minus that 5. Now be careful, you cannot minus the 5 from the 3. This 3 is a part of the logarithm, the 5 is not. And then the final step is just to divide by 3. So my final equation is y equals log base 4 of x plus 3 minus 5 all over 3. So for these, you're not actually solving for a value, you are rearranging the function to get the inverse of it. So that is the first example. Now we're going to do this one. Step 1 is switch x and y. From here, I need to get this log by itself. So the last equation we did started out as an exponent, so that means I'm going to end up having to log it to get the answer. This equation started out as a log, so I'm going to have to make it an exponent to get the answer. But before I can do that, I need to get rid of that negative 2, excuse me, off the front. Anytime you divide by a negative, just note the proper way is to put the negative on top, just so no one's confused there. Now that I have just the log and the argument, I can rewrite this as an exponent. And then my final step here is going to be to add 1. So my final inverse equation is y equals 4 to the negative x over 2 plus 1. Keep in mind, I cannot add that 1 to the 4 because that 4 has an exponent and the 1 does not. So that is my final answer. We're going to do one more example together, and this one I'll do with a natural log. Oops, I forgot to put y equals. Okay. So step 1 is switch x and y. From here, I need to get it so that it is just the base and the exponent. So I need to get rid of this divide 8 first, and you get rid of that with a times 8. And now I'm going to get rid of this 3, so we're going to divide by 3. Now I have it just to a base and an exponent. When I have it here, I can log it, but because my base is e, this is a natural log. So I have natural log of 8x over 3 equals 4y. Last step is to divide by 4. So my final equation, I'll write it over here, my final inverse equation is y equals the natural log of 8x over 3 all over 4. So guys, that is how you do inverses with logs and exponential functions.